Okay, let's get into our topic. Yesterday we are on the topic of Docker image, right? Let's get into that topic. Docker image. Docker image. So basically, if I want to give a sample definition or a single definition, so it is something which nothing but the combining of bins and libs with the dependencies and plugins and all, which is going to execute your runtime container. So that is your image. So where the container can come up with your image, container will come up with your image only. So if this container need to be executed, then your image should be clear, that is packaging all the things. Like what are all the things it is going to package inside? As I said, bins and libs. If in detail we talk about database, binaries and config files and dependencies, libs, okay, all these are going to be packaged as image. So whenever you're going to run it as a container, you can call this container is runtime. What happens here? Runtime. Docker is your runtime where your image is going to be extracted inside this container. Run it as a service. Run it as a service. We already seen yesterday that we also seen some example of pulling one image and did something. Okay. So this is that the general statement I can give you what is an image. If you are facing an interviews like the multiple questions or a follow-up questions over these images, you can also add in deep like images are immutable. I would say these images are immutable. In Amazon interview, so this question being asked, so that's why I'm telling you immutable. So what is mean by immutable? Once an image created, it can't be edited or modified. So that one we call it as immutable. Mutable means we can edit or we can do some modifications in it. Once you created, you can do that. So that is mutable. Immutable is something you can't modify it. You can only make a new image or you can add the changes on top of it. On top of it to your container.
ఈరోజు జూమ్ పెట్టిండు బ్రో నేను షేర్ చేస్తాను.
Please go on mute. Okay. Now we know about this image that is it's immutable. So as I'm saying that we can go and add something on top of it. How we can now it is going to be a
జూమ్ ఇన్స్టా
container.
జూమ్ ఇండస్ట్రీ ఆ లింక్ లింక్
Please go mute. Please check your mic if you're speaking. Fine. So here, what I'm telling, we are going to add a top of things that is container images. Okay. When you compose the image, there will be a layer added on top of it. So there are many layers. There are many layers. Whenever you add run instruction in the Docker file, it will add a layer. Whenever you add a run instruction, okay, it will add a layer. So while you're adding the layers, each
Hmm?
layer, each layer represent a file system, represent a file system, so that you can
Hmm.
add, remove, modify files, all these things you can do. So these are the main two principles of your Docker image. If any candidate in interview is asking particularly what do you know about Docker image, what exactly it is, then you can say it like this. Okay. So in deep subject we would say, but most of the people will not ask you that. Can you just give me a clarity on the Docker image, what it is, how does it can be? Okay. So you can give it that. Just a minute, I'm getting a call. Yeah, sorry. Okay, so can you please explain one more, that the layer point? Okay, so layer is when you image is composed, means with a Docker file, when your image is composed with some of the instruction you're adding from, copy, add, run, all these things you are doing, right? When you add a run instruction, it will add a layer in your composed image. Like when your image is going to be created, that's what we call compose. Like we're designing, we're telling some instruction to become like this. Okay, that's what we call compose. So when your image is going to execute as a container, in between these run instructions are going to add the layers. So these layers are nothing but it represents the file system in your base image. Okay, we'll come to that base image part also. It's going to represent base image. Inside the base image, it is going to add the all the file system. Okay, here you can add, remove, modify the files with your when you are executing the container. Okay, so that's what these two principles work with your Docker image. Okay, extendedly, I would say. On existing images, if you want to do something, then you can do with run instruction where you are executing the container. So this is the first what we need to know about the Docker image.
So means suppose in Docker file we have form, then
Hmm,
working directory. So
hmm.
form is one layer, work directory is another layer, copy is another layer.
It's a four-layered Docker file, and in that, if you add run instruction multiple times, because in the run, what you will do, run npm install, run something install, git install, or you are bringing up any libraries, right? So that is going to add into your libs directory or usr share directory, or somewhere it is going to download, right?
Yes, yes.
Basically in the server. So that is a file system, right? So that is a layer. That's add as a layer. Okay. Basically, whenever what is a Docker file, you can generally give a statement that is a four-layer Docker file. It's structured with the four layers. But It also going to include much more layers when you add the instructions in it. It's not about it only going to be 4 layer. It only going to be 2 layer. But generally it is a 4 layer Docker file. Okay. So to get these images, we know that you can go to the Docker registry where you can find your all the images, whatever the sponsored, verified, and OSS. Now we need to understand two things according to the Docker registry.
చాలా తిన్నావు కదా ఇంకే జనాలు పర్క్ తింటే వస్తుంది వాడికి
Fine. Okay. We have two things like according to the Docker client architecture. So after this, we'll directly go to our thing, Docker client and Docker daemon, which is Docker engine, and we do have Docker registry. So Docker registry assess Docker repository. Okay. Registry is something where you can find all open images. All open images. So when your Docker client is communicating with your Docker engine, in order to generate any image, you are running something command called docker run here, okay, or docker build here. Docker run or docker build, something you are giving, and it is going and running, and it is giving you output inside this server. But what does mean by this registry? So this registry is in few types in the organization. The first one is ECR at the AWS, ACR, Azure, GCR at the Google, Elastic Container Registry, Azure Container Registry, Google Container Registry. If not, then your Docker registry, open and enterprise, both. Docker registry or a container registry, both terminologies you can call. But inside this, there will be a repository. Okay. Now, I want to create an image. I need a base image or I need some packages. So all these images are already available at Docker registry, were openly available. Okay. If I go to Docker Hub, click on the Docker Hub. And go to your Explore. So these are all open images where there is no repositories, but you have an option called repositories and organizations. If you click on the repositories, there is no repository as of now for me. And click on the organization, there is no enterprise organization that I have not yet created. Okay. Companies, if they are adopting for enterprise account, then they will create an organization. Under the organization, will create the repositories. Okay. Now this repository is same in your ECR or ACR, GCR. But whatever the open images you are seeing, the public images, you will not see in this ECR and ACR. It's your cloud native service. You will not able to find your public images over there. If you want to pull any public image, again, the Docker will automatically pull from Docker Hub if it is having the internet connectivity. Either your server or a cluster or your pipeline running in the private subnet, it won't. If it is running in the public subnet, then surely it is going to pull it. Okay. But in the ECR and ACR, what things will be present? In this, we are going to create a repositories. In this, we are going to create a repositories. Whatever the Docker image is generating here, so this image is going to upload here after scanning. Remember, after scanning, it is going to upload here. We're going to discuss the scanning also. It's going to upload after scanning. So that's what happened. The scanned image is the one which we can recommend to the production side. If it is a unscanned or it finds some vulnerabilities, your pipeline may get failed. Your pipeline will get failed automatically. So you need to sort it out. That is your job. Why it got failed. That's how where DevSecOps will come into the picture. Okay. So this image is going to upload, and repository is something that your organization specific. Your organization specific. And when whenever you are uploading this image, there will be a tag. We call tag. Tag is something in some organizations, it is build number. In some organizations, it is model number with year, with month, with date, and some random ID. In some organizations. In some organizations, it is your GitHub SHA ID. GitHub SHA ID. Whenever you do GitHub action, it done commit, the SHA ID is going to be a Docker image tag. In some organization, it is you are having a release tag, right? In GitHub, we discussed feature branch, release branch, and develop branch, the hierarchy, hotfix, bug fix. Does anyone remember? Tagging. Tagging. Can somebody recall that? What is mean by tagging?
Like versioning.
Just
Code
we are
release,
giving a name.
not the name. It's the version. Like we
Yeah,
give a
well,
version like 1.1.12 like this.
yes, yes, sir.
So this represents what? Hot fix or bug fix, a small fixes. This represents major minor fix. This represents major fix. The version fix, it's a major fix. So these kind of tags are going to be at your Docker image. So it depends on your organization how they are following the structure. You always need to stick to the process in an organization. Don't be like that here something they are following in another organization is the same. No. DevOps is same, but I'm teaching in a different way. Somebody is teaching in a different way, right? Same way. The work culture is different. The process is different. We need to know the process because the architecture is developed like that. The flow they have developed like that. We need to follow that. Okay. So this is what we need to know how the tagging will be happen. So if you are working on an existing project, already this tagging system with regex and all is going to be given. No need to worry. If not, if you're going to develop, then you have to plan like this. If you are giving a solution, then you have to plan like this. Okay. Then after our Docker image, the scanning is happening. The scanning is happening, I'm telling you, right? Scan. So this scan into different types. Okay, different types. So there are what we are going to find out in the Docker scanning. Like if I use a sneak or if I use a something tool, then it is going to scan and it will give some output for me. What output, what scanning things are parameters I need to ensure that while it is, even though you are doing through your CI/CD pipelines, and you need to find out. You
We
need to
use
find
so
out.
code SonarQube in Java.
No, not the Sonar Cube. Sonar Cube is it's your left.
Code vulnerability.
Yes. Before
Here
Docker image,
we are
before
using
Docker,
image vulnerability, na? Here we are using image vulnerability,
yeah,
scanning the images.
before your Docker image, your code is to be standard code. For that, you're doing a static analysis with the Sonar Cube or a
Yeah.
Vera code, okay,
Yes, yes.
or Sonar Hub. With that, you will get to know the code standard. But after that, it is not having the capabilities of scanning the containerization technique, right? Sonar Cube is not having the technique. Now we have a separate tools that it is going to do a scanning over the image once you converted. So if you are generating some node modules, SonarCube will not consider your node modules or some other modules, some other packages. It will ignore because it's something good to the if it is a vulnerability not identified at your SonarCube quality gateway, then it is a problem at the Docker Hub, sorry, Docker image. Then how it is going to be identified? You can't blindly go for it. You need to always scan for it. If you are doing try and or a Docker scan, even though here also we can, if you go enterprise, here Docker scan also will be available. And if you are cloud native service, there also Docker scan is available at the repository. And if you are going with any Anchor product like tool, so that is also very good enterprise tool to do the scanning. What are all the things it is going to do a scan? First, we talk about the vulnerabilities. So what it will do, first of all, it will track or it will check vulnerabilities, and then it will check packages, and then it will give you severity and version. So these are the basic things. First, it will provide you in terms of your scanning. Okay. If this version, severity, packages are not up to the mark, then what happens? It is going to give you a fix of the version, URL, or something it is going to give you. So this is the main thing that when the Docker image is scanning, okay, and these results are going to upload to a S3 again. Where it is going to upload to a S3 again. This is a log. The scanning log is going to upload here only. Where do you going to store these logs? You need to store it somewhere. Please go mute. I said multiple times. Yeah. So this severity can be a critical, high, medium, and low. If this Docker image severity is found as critical, then you must and should attention, like immediate attention you have to give it. Or it is high, then you need to resolve it in that day itself. Medium, then you can have some time to do it. Low means whenever you get some time, you can fix it up. So this kind of things, mostly DevOps is going to work if it is going to fail at your Docker image scanning build. Okay. So that's what image side we need to know. So this scanning we can call it is a left shift testing. Left shift testing. Left shift testing means SonarCube analysis and Docker scanning is, you can call it as left shift testing and right shift testing. Left shift testing, these things are included. Right shift testing is your UAT environment. We call UAT environment, right, where testers will come and do the testing with Selenium or the something. So that is right shift testing, where at lower environment with application it happens. But before it create an application, you're doing some kind of a testing, that is left shift testing. Okay. Now let's understand in deeper about our container. Now to understand the container in deep, uh, what I would say, give me a minute, getting 1 minute, guys. Yeah, sorry. Where are we? We need to understand in deeper about the Docker container. Okay. So Docker containers are, I would say some features I would like to discuss. Docker containers are self-contained. Let me write it down. Self-contained. So self-contained means each container is having its own function or its own need that it can do a pre-installed dependencies on the host machine. To make you like more clear, self-contained in the sense, if I am running or executing this container, so some of the dependencies need to be installed with your run instruction, because I am telling there is a base image. Who are not getting this, please hold with me. I'll tell you very clearly. Base image is going to your host. You're going to your host. So inside the image extraction has to be happened. So you need some of the dependencies to be done. If not, then the each container, whatever you are running, it is trying to pull out the dependencies. If it is not able to find out, then it will give you an error, exit code 0, exit code 01. Like this, it will exit. So that's how whenever you type docker ps, you're not able to see container. When you give -a only, you can able to see the container. When you give the command, it's a hidden container because it exit. It's not able to self heal itself, even though it's not able to find dependencies. It's trying to do it, but it's not able to. So it is self-contained, that it's trying to execute the function. Now, Docker container is an isolated container. It's an isolated container. Container run with all the isolation, like it's not going to communicate with other containers. So we have a host and other containers. So there will be a network difference between all the containers. So Docker networks, we can call them. Okay, we have MVC and bridge networks and custom networks and all. We're going to discuss that. But basically, when you run any container, that container is going to run on a bridge network, so that you can communicate one network to another, uh, one container to another container. But if you don't want to connect the container, you can run the container in one network. You can run another container into the another network. So in this way, you can be isolated. You can be isolated. So where we going to see this? How we going to implement this? When Docker's clusters are there, Docker swarms are there, that time we use it to do this one. But nowadays, we are with almost with the Kubernetes, so we are not doing. We are handling the network at the Kubernetes level. In some of the projects, so there are some of the Docker clusters where shell script files are there or Docker Compose files are there. They're executing the Docker Compose files into a server. Still, those kind of projects are there. that is a legacy projects. If you are going to work on those kind of projects, mostly you can find out on the Capgemini side, Capgemini company, or Tech Mahindra also having those kind of projects. So you may see this kind of uh, deployment strategy. Okay, where do you run the compose files manually, because they are legacy, too legacy. So in this case, in that file, there will be everything will be listed: network, image, everything into the one script, just one script, one repository, one script that is going to run into a separate namespace into your server. So this kind of structured projects also there, for the information I'm giving you, but mostly you're not going to be fine. If that's your bad luck, if you're going to you never get a good subject, it's almost everything is legacy, you will be stuck over the container itself. Again, container is independent. Container is independent. Container is independently managed. Deleting. If you delete the one container, other container will not affect. This is what the microservices concept. Microservices. What is microservices and monolithic? Lithic. Anyone?
If running two containers, if one is down, another one is up, and it means it will not down, right?
For every service, we have a container. So every container is a service. Suppose login is a service, purchase is a service, order is a service. So all the services are running on the containers.
Okay, let me tell you that.
And monolithic means suppose after cloning, one build is coming, and that build we are deploying into a Tomcat. That will be monolithic.
Okay, so let me take.
Multiple nodes, one node is down, another will all automatically run. That will not affect other nodes, right? Maybe that kind of thing, I think so.
Like, I just open one website. If you see this website,
In
what
Microsoft, lot of services inside the container. In monolithic, one inside one container, there are different services.
sorry, can you repeat one more time?
In microservices, in one server, there are different containers, or we can take multiple servers also. In monolithic, in one container, we have different services.
No, not like that. Let me tell you.
Like monolithic is dependent, like every service is dependent on one architecture. Microservices, even if one fails, one service fails, the other service is not interlinked to each other, so the other services will work.
Yes. If you see this website, what do you think? It is a microservice or a monolithic?
Microservice.
This is
Mic
a
Microservice.
microservice because
mm,
mobiles, fashion, electronics, all are independent. Uh,
okay. Now what I can see here, become seller, one option, cart, one option, login and register, one option, and I can see search, one option, and this is product catalog is a one option, and other options, order, payment. Like I have other two options, and I do have an option, recommendation, right? So like suggestions, we get recommendations, and also we get this application you're seeing, right? It's a full stack front end. And behind the scene, there is an API. There is an API. And in between, you should be authenticated, some auth service. And when you are logging here, you become a user of this, right? User service. When you logged in and you created registered, you will get an email, right? Email service, mail communication. Okay, communication service. You get the phone number and messaging, communication services. How many things I have listed? Whatever the option I'm telling here is everything is one microservice, and each microservice is one container. Is one container. Now, each this front end, API, auth, user, email, communication, login, whatever I'm telling, this login is a separate repository. One repo. Cart is one repository. Become seller is one repository. API is one repository. Front end is one repository. User is one repository. And for each repository, there is a separate CI/CD pipeline. For each repository, there is a separate CI/CD pipeline. For this also, there is a separate CI/CD pipeline. And for each this service, there is a separate Docker image, and that is going to run it as a container. That is going to run it as a container. Now, if a developer wants to do some update at user repository, because we need to update something at the user profile. User login style should be changed. An example. So developer will come and did changes in the user repository. CI/CD pipeline will be run, and then it will create an image, and that image will run it as a container. That will reflect here in this application. So when this going to be do a changes, and while it is deploying, your other services will not affect. This is called decoupled method. Okay, decoupled method. So while user is deploying, you can do cart. If some user is already logged in here, he can do cart. Other functionalities will work. Only this specific functionality, if it is get failed, this specific functionality only will not work, but other functions will work. This is decoupled method. That is what microservices means. If it is a decoupled method, then how my user is communicate with the email, and how this login is going to communicate with my DB, MongoDB, how this cart is going to communicate with my order, how this order is going to communicate with payment. All decoupled, right? One service to another service, there's no connection, as I'm saying. Then how is all going to connect? From the source code point of view, from the CI/CD pipeline point of view, these all separate lines, separate roads. All roads will come and join at one point, that is deployment environment, like your production, staging, UAT. Now production is the final one, okay, where everything will be running inside the production. But there, how this all services will be connected? I clearly mentioned that these all containers are isolated containers.
So through APIs.
Exactly. It's going to communicate with API. Okay, if I have one service with, when I click on this, it's going to run a backend function, and that will communicate with the API. Okay, with your backend and with your front end, the API is going to communicate and it will give the data. If you click on somewhere like my profile or something or orders, It's asking me this one.
Because one backend API will call another backend API.
It's not like in one application there'll be a one API, there'll be multiple APIs.
Yeah, yeah.
Okay. If I open this page, you can see here it is updated something. And how can I find this request? So we're going to see something. If you come down here, more tools, developer tools, and do a refresh. So this is your code is running. Okay. And whenever you see 200 code, so this is successful. 200 code means it is successful request happen. Sometimes you're going to, this is not going to load. This is something going to give you error. Then here you can able to see 403, 401, 503, 5. Here it will not show, but here it will show. This is how you need to do a troubleshoot. When you are working on a production scale, an incident happen, it's come and landed in your bucket. How do you solve it? You are an SRE now. You are SR engineer. How do you? That's assigned to you. First, what you will check? The ticket is clearly telling that hey, when a user is logging in, he's able to sign up, but after that he can't able to see anything, or he's not receiving a mail, or is something happening. He'll tell like this, all these things. How this is going to be troubleshooted?
We
That's
will
an
see
impact.
the we will see the logs of that
What log you will see?
service.
And now you don't know the which pod or which container is down,
Yeah, yeah, yeah.
right?
And
How
we can do
If the pod
inspect.
running or not, and then we'll check the APIs are correctly pointed or not, or interest file will check other like that.
No. First of all, user is complained about a incident happened. The incident is telling that it's not able to place a order. Multiple users are not able to place an order. How do you find where it is an issue? First, what you'll do, you directly jump into the Kubernetes cluster and run kubectl get pods -n in production, and then you will see the status. And order pod is running actually one by one successfully. It is running order pod, but order is not happening. Real time case. Yes, we will see it in while you're working.
Can you check the log?
Which logs you will check?
The Docker logs or
First, you need to make a habit of logging into the application, and there are some scenarios where you can fix it up itself in the application, that no need of come to your cluster side also. This is our way of thinking. See, in application itself, there are some settings need to be done, right? Every application, you take Netflix or anything, so there are some settings has to be done. You are as a user, you don't have a kind of roles, but in the same application there will be a candidate who is having some admin roles, like you and me. I am a teacher in this Zoom meeting and you are a student. You don't have a option called record, but I have an option called record. The same thing happens at application as well. So when any ticket is landed, you need to understand what was the root cause. So their application support team will come into the picture. Application support team will do that. If they cannot able to do, then the ticket will be drive to you or a developer to do a code debugging. Now we need to understand that why it is happening. It's not directly land to a developer also. Developer simply says that SRE has to drive this ticket. First of all, it will not directly go to developer also. First, SRE has to be drive this ticket. So the people who are working at the production scale, they have to look into it. Now you will come like this as a user and you will see it here what happened, or you will see the logs which user is given in the incident. You see it what code you are getting here. Most probably you can understand, and if not, you can able to open up these things. You can able to find it out at where it is requesting to and what happening, which request, get, post, what happening. Is it just fetching the information, or going and posting something? That you need to understand that how this action is going on here, because this is API based communications, application program interface. So next level, what communicate? API will be communicated. In the API, the developer is going to give the every code, like how the body type has to be come back and print into the front end side. Okay, so that's we need to check. If the order service is running, but it trying to communicate with the API is down. You need to check API container, or API container also up. Now what do you check? In between, you need to check the service. When it is going and communicating with the API service, that why it is not happening. There could be some issues. What issues? There are two types of issues again. If your microservices are running very normal over the communicating cluster, let's say here one service is there, here one service is there. So you have just given some ingress controller which need to be do communicate between these two, even though they are in different namespace or something. Okay. Who are already working, they'll get to know. Just for information I'm giving, we'll come back. But what happens here? This service need to communicate with this service, and these are different services which having a different functionalities. So we are not just directly going to give a direct communication between the services in the microservices. We use something called between to communicate queue process, queuing. Okay, queue process. What is
Message
this?
queues. Message queues.
Yes,
Kafka.
Kafka, SQS, and service
Yes.
bus,
Kafka is used basically.
RabbitMQ. These kind of things.
Basically, developer work. Spring Boot developer.
It's a service between to communicate between the services you're going to use. If these microservices architectures are going to use queuing process, that on a based on the request that it is going to subscribe and publish. This is what happens at the microservice, and it's quite opposite to monolithic. That's it. Monolithic is something, if this service, if I'm doing some changes, I need to down this service. The whole application I need to take a downtime. So that is monolithic legacy applications. Okay. Now independent, that's what our microservices. Independent and portable. And portable. These are the main features. I can run anywhere this container. On any of the base operating system, I can run this. Okay. And we already compared virtual machine and container differences yesterday. So I hope should not means it's enough subject. We know already that what happens at the virtual machine and what happens at the container. Container is, these are the things like it is very portable that you can run on any of the operating system. Now, while I'll go with the understanding the image layers, let me uh, let me tell you about something deep. Let me stock image. first what happens when whenever you're going to create your image, or whenever you're going to make use of images. For example, the hierarchy will be like this. First, what happens? There will be a app source. Why I'm telling this? Because you might going to troubleshoot this. You have to do this app dependencies, and then there will be a app requirement, and then there will be a your, let's say, your packages. If you are talking about the Python, then it is a pip, and you have your base image. You can see some chart. Source code, yes. App source means source code. Okay. So this is how your image structure is. Okay. In the first layer, uh, it add some of your basic package managers, such as your source code with package managing. And second layer, where it is going to add some dependencies with your runtime. If you are using for JDK runtime. If it is using the Node runtime, or .NET SDK runtime, like this. And then the third one is like app requirements, where it installs specific requirements into your image. And the fourth layer is going to be specific dependencies, like when you install for Python, pip, if it is for Node.js, npm, like this. And then all these are going to be copied into your base image. Okay. So this is how it going to work your image. Okay. But whenever you enable your base image, like you're taking a Ubuntu or Debian, anything, so that will come up with an one ID. The ID is always going to be vary with your container. It depends on the image that you are pulling from the remote repository. So whenever you log in into the app, it will give you a random ID, but it's not employing anything much in your troubleshooting. But you to identify your image structuring, the ID will help you to do troubleshooting in deep. In some of the organization, if you take open text kind of open text companies, then they will not depending on the any of the third party images. They develop their own image, their own image, like with their hands. Their employees only develop in their the employees, whatever the image they develop, on that only they'll run the things, because they don't want to get into a risk. That's their policy. Everything is developing in the open text with their developers only. Okay, that time it is a matter. Okay, now let's move to the understanding the Docker file in order to create this Docker image. Okay, let me write down a Docker file. What we need to understand? We need to understand a Docker file. First one is from. From is a base image, as I said. Base image means this is your container. It is going to run it as your server. And then you're going to add work directory. What work directory? If you're calling above base image as Python or SDK or something JDK, anything you are calling, that is your runtime. In this server, You are telling with work directory, create one directory. Create one directory. You're telling like this. Create one directory inside. Okay, it will go and create. And then what do? You do copy. What you will say? Copy. What you want to copy? Copy. What happens in the copy? This is your server. This is your server. And this is your Docker file. This is your Docker file. And this is going to be your container. It's going to be a container. What happens here when you're writing from this Python is your going to be a container, main container. Inside this container, it's creating one USR app a path. Okay. Now you are telling copy dot means whatever there inside this server. There's some stuff. There are some files. This all files you can copy into this slash app directory into this container. Into this container. Now you're telling it as slash usr slash app. If you give directly app, it won't work because before there's a usr there. If you are directly creating app, then it will copy into the app. If you give dot, everything from your trash files also in the current directory, everything is going to copy. But you want only specific file, then mention a specific file here like abc.txt. It
It
only
means
copy
everything will copy from the server to the container.
container, not everything from the server. The Docker file where it is, the present working directory. If you
Yeah.
give pwd, whatever there itself, everything is going to copy into the container.
Make it very simple. Don't take it too serious.
Please go mute. Okay. Here, then copy something that I'm not satisfied. Then what else I can add? Add instruction. Okay. In add, what happens? Hey, I have JFrog here. I have JFrog or an Nexus here. Okay. So here what happens? There are some packages. There are something there which I need to copy into my container. So this JFrog to this server, it is having an access. So what I'll do? I'll write down this here and I'll give the path slash usr slash app like this. So from online, if you want to download something into your container, that is going to happen with your add. That's going to happen with your add. So here, no need of downloading into your server. You can also do that. How? You can add a run instruction here. You can add a run instruction, give a wget URL. It will copy, means it will download, right? Then you can copy. It works. But what happens here? One more layer is adding here. If this layer is adding here means Docker image is going to create more. The space is going to create more. Okay. What is this? The execution time also more. While it is running, execution time also more. So you don't want like this. That you can utilize your add directly into your container from your online to copy inside the container. Now, second thing, run. Specific dependencies. Inside this Python, I have a source code. Then what I need to run? I have some packages requirement.txt. or packet.json or CSPros in .NET. Okay, so like this, we'll be having some packages that need to be run according to our source code. It comes with the source code. If these packages are not there, then your source code will not run any of the server. That is very mandatory that the developer has to keep these things. Okay, so we are going to keep this run to install some specific dependencies. And then what else? We are going with expose 8080 or 3000 or 5000. This is going to be a default port number of your code, that actually on what base it has to run. You need to give, developer is going to give you that port number. Then you need to ask if you don't know. You need to ask the developer that if you don't know, if you're writing a Docker file. Then you can add CMD. You can add CMD. Add is optional depending on the case, right? Yes, as I said, if you want to add something, you can from the online that you can use. If you just want to copy something, you can just copy. You can use the copy instruction. Now here it is CMD. In CMD, what happens? CMD is actually going to run your container, execute your container. Python, this all the things are going to run it as a container. Okay. Here you will write some arguments, flags, arguments. Okay. Now I want to run this Python. So what I'll give? Python. This is one command. This is one command. And then what is the file I want to run? app.py. This is one, and close it. Like this, you will do it. Then it is going to run. If you are running the same Python code in the server, then Python 3 app.py. Directly it will going to run. The same thing you are writing in this Docker file like this. Python, comma, app.py. If you want some extra things, then you can add some flags in between. Okay, we'll discuss the flags also. So you can add some flags, or there will be an entry point. Entry point also same. It execute, same thing. Now you most of the interview questions you covered here. What is the difference between copy and add? What is the difference between run and copy? What is from image? Can you explain the Docker file? Can you write the Docker file? Okay. Now the thing is left. What is the difference between CMD and entry point? Can anyone try to explain me? If no, if you know.
It will regarding these parameters only. So one will override the parameters, and in basically two parameters will be there. So in one thing, it will execute last, and CMD will execute both.
Anyone? If we know
Both will
why.
execute both CMD and entry point. Both will run this app.py. But
Nah,
the
both will
difference
run.
between both will run the app.py.
Hmm.
So pip py app.py, but main difference will be in the parameters and overriding of parameters.
Yes. Overriding of the parameters. How can you make it very clear to the students? How can I understand? Then I'm not technical person. I'm just newbie here. If we know why I'll join your class, right? So how we can explain this thing? See, CMD is something it will ignored by Docker daemon. An entry point will not ignored by Docker daemon. In this case, what happens? Now I am telling that the CMD run Python app.py only. While it is executing it as a container, it will run Python app.py only. While you're giving docker run command and image ID, and you are passing something externally, then it will prioritize this one, not this one, not this one. It will prioritize this one. So it means it is ignored. It is ignored. It will only prioritize the external one what you are giving. It's only execute this one. So in the entry point, what happens? It will also going to run this, and whatever you're giving externally also going to run that. It will not ignore. Now to make you give you a good example, so I'll say hello Python. So while I'm executing, it will give me hello Python. If you give while you're running container, and I'll say hello node, docker run node, then it will only print hello node. It will ignore Python. But I don't want this. I want this both. That can happen with the entry point. So that's why most of the times you will see entry point and CMD in the your Docker file. In most of organization, you can able to see both. It depends on your options, the repository, the code base. You want the thing that what the things you want to execute as a container. Okay, you can able to find the both also. Can I give entry point in the first and CMD in the last? No, entry point is in the last. If entry point already executed, then the CMD will no, right, it is ignored. So CMD is the first and entry point in the last. So this is what the Docker file is. This is one type of Docker file.
Actually, sir, I asked KT why there is why CMD and is there not entry point? They don't give me the clear answer.
Who?
So when I asked why entry point is there, CMD not there, they said that somebody else has written. We don't know.
Mm-hmm. Yeah, that's
CMD
why.
is like default.
Somebody else has written this. So they said that like this. We don't know. 4 years before, 5 years before.
Yeah. See, why should we use both in the sense if your code is very bigger and you want to execute the specific things before your container, going to be execute as actual container, you want to execute few related options or few related functions before the container, then you can use CMD, and then you can run it as a execute the container with the entry point. That is a use case that few people will use the CMD and entry point both. Okay, it depends on the functionals and functionality of your service that the repository you are going to build. Okay, if whatever the things that you want to execute, it's ultimately the things want to execute inside the container. Okay, for that we cannot give the entry point very longer to execute all the things. I cannot give 4 5 6 services to be run in the entry point. I can give hardly 2. Whatever, if I have 3, how? I want test cases to be executed, so I'll give CMD for test cases executed before it is running as a container. Then after test execution is passed, then I can give a container. So entry point will go and create a container. It is something like not like, but you can compare like a init container at your pod. Here also we can do that actually. Okay, so there's much deeper subject in this Docker file. If I want to tell you, there will be 2 3 classes can be happen. I need to also tell you about the maintainer, user, environments, multiple things I need to tell. It's not only this instruction. There are around 15 to 22 instructions that we can write down in this Docker file. Okay.
So can you give demo one time write the CMD, one time write the entry point? So what will be your difference?
Yeah. So we are going with the sequence. Let me complete this Docker files and I'll come to that point with the execution. Okay. Don't worry. Now, there's a simple thing. You can just go and run it out in yourself and create a killer coda, give hello and give Vidit here, and then entry point, give hello, give Vidit here, and in the last you can run Gupta. You will get to understand easily. Okay. But let me cover up one more type of Docker file today so that we can directly jump into the practicals from tomorrow. So it is not going to waste the time.
Actually, I asked developer also
Hmm.
why this is written. So all people say that it is written years before. We don't know.
No, you just while the class is going on, go and create and tell me why the class. Okay, if you want to do practice. Okay, now there's a one more Docker file type. Is that multi-stage Docker file? Multi-stage Docker file. Why we need to go for a multi-stage Docker file when I have one type of Docker file? Can anyone again? If you want to add something, your comments.
Suppose in this file, there will be the size of the image will be more. So to reduce the size of the image, we are using multi-stage build. So we will be using two from
minimalistic images like that we can use distortion issues.
optimize the file, optimize the image size.
Optimizing the image size. Okay.
Yeah.
So when I go and do this, since here the layers are adding, and what happens here, basically what I need when I'm copying these things to this app, in this app with this run requirements, it is installing all the things and app.py is running. The service is running inside the container. Okay. But it is having all the things. When requirement.txt is running, it will install like many of the things, many like to whatever the Python service need to run, dependencies, libraries, packages, versions, scope, many things it is going to download into a container where it use the file system more, where it use file system more. That's how the image size will be bigger. Now I want to reduce it. How can I do it? So that's going to done with your multi-stage Docker file. Now here what you add in the multi-stage Docker file. So you're going to add same two froms. Add two froms. So please go on mute. Okay. In the first what happens, in the second what happens. So first one is always a slim version. First one is always a slim version. You can take a slim version image and here you can add like slim version image, slim version, and then you can give as a builder. You need to add this. The first one you can add it as builder. So what is mean by a builder? In terms of your CI/CD, whatever you are packaging the code, before Docker file, you can also package. Yes, before a Docker file, you can also package in order to support. If it's a very big repository, one bunch of dependencies there, and it's very hard to do a containerization directly. See, there is a method you cannot do directly containerization. Before Docker build, you have to build again. And what that build happened, then you can copy that. So in that case, single stage Docker file. So no need of for it. because the build is already happening before the Docker image building. So you can only copy package. But now here, when I'm directly coming towards the Docker file to build, and I have a very big repository, and like very big things are there. So what I need to do, I need to use this multi-stage. So what happens here in this builder, the code is copying from my server. Let me decrease it like small, and then I'll keep it here. Now it is a builder. This code is going to copy into this, and here it will generate a package. Here it will generate a package in this first from. In this first from, it will generate the package. And this package, we are going to copy into the second from base image. Only package. So you have lot of trash things here, right? Lot of files. You're not concentrating all this. For an example, if you all know node modules you don't want to copy, or Java thing. If you take the Java, you generated a var. Along with the var, there are multiple files are there. Why to copy multiple files? You need only var file, right? Copy the var file to here and run the var file. That's it. So this is going to run it as your container, not this one. This is going to run it as your container. So your image size will be very less rather than comparing with the previous one, right? So this is how we use the multi-stage Docker file. We are going to execute these things. So
So
please be
what I notice is that suppose if we are using Maven, then first upper part will be from Maven and down part will be from OpenJDK 17.
for you. Let me write down to clear understanding. So what I'll take here, first I'll take a JDK Gemi image,
JDK 11 too.
okay, as a builder, okay, and then I'll give a work directory, and I'm giving opt/app, okay, and then I'm telling that copy .mvn all the things to my .mvn, because in Gemi there's a mvn, okay, for this Spring Boot project I'm telling. And now you can give a copy also one more time and do mvnw, then you can give pom.xml. This is what you need to build as a mvn. So the mvn things are going to copy into your mvn, and then it is going to build your pom.xml. How you can going to build pom.xml? You have to pass uh, slash, I think, yeah, slash mvnw. You can run it like anything. If you specifically want to go with any dependency file, or you want to go offline, you can also try it out. And then you can run it slash mvnw clean install. Okay, now two layers are going to be added. Now what happens here, it is going to generate what? A jar or a var. What it generates? Jar or a var. Let's say Spring Boot jar, it is going to generate it. So this one I want to copy. Now I'm going to use from. Now I'll use Gemi. Now you can give it as a final one, final content, final image. Now you can give work directory and /opt/app, and here you can give expose like if you want to expose with 8080 and then expose, copy what you want to expose, like clearly see it from builder above, from above builder opt app. You have a opt app, right? There itself your Pom.xml XML is created something. So inside that there's a target folder. From there is a jar file. Okay, there's a jar file. So take this, copy that from the from and copy into this container opt
OPT app
app
target.
dot jar. Here you
Okay.
no need of target, okay, because you are copying from here to here. Okay, copying someone is sample multi-stage docker file, Rahman Sheikh. Okay, see, here to here it is copying. Now what you do here, what you'll write down an entry point. Now give it entry point java
Execute
space
this jar file.
-jar. We also run Jenkins, right? You can run the Jenkins via jar. And now what do you need to
Yes,
give?
yes.
It is a jar. Now we have to give opt/app/star.jar. This is how your Docker file look like. Now what happens here? The var or a jar it is generating here in this Jemmy builder. Here, from here, this jar take, because this jar is going to generate in this path here. Copy this and keep it into this container one, and then executing a entry point. That's it. So this is how the multi-stage Docker file will work.
Okay.
Okay. So please be very careful that whatever we're discussing are all the things are going to be executed as a practical. And when I'm going to assign you the task, and don't be confused, complete your task. We are going to do with a CI/CD once set of classes done. So I need to make sure that the foundation should be very nice. Docker is a foundation. Okay. We are going to write, we are taking a code and we are going to run it as a container. And don't be upset that, sorry, don't be very shocked that, hey, there's a multi-stage Docker file, there's a single stage Docker file. Now you get to know the use case. You know the instructions, right? You know the container requirement also. You know that the image requirement also. All these are going to be in our practicals in coming sessions.
So do we need to remember these paths and all?
You need to have an idea, not exactly not to remember, but you need to have an idea so you can easily identify it. It's very easy that this is a Java code. If it is a NPM code, some another path. If it is an Angular code, some another path. If it is something .NET is another path. If you don't know that how to write a Docker file, no need to worry. Come Docker Hub, go to the Explore. Which image you would like to? You want to go with a multi-stage. Let's say SDK. SDK is a .NET. Sorry, DSK. SDK. Okay, this is a sponsored one. Verified. Anything. Let's say you are taking this image. You don't know how to write it. He has not written anything. He just published. Let me take it out. Docker official. So I have something called this Java image, and I don't know how to write it. Okay, come down. Come down, come down. Here we can able to find out what is a path, how to write, creating a Docker file. Okay. If you are using a class data sharing feature, this is the path. And if you are, yes, most probably if you're using this image, then you can. If I'll just come to Jemmy, okay. Jemmy image, any Jemmy image, just take, it didn't done anything. I'll just go with the official or verified. Core Ubuntu Jemmy is there. If you come down, it's not even mentioned. Here also you're not able to find it. See, if most it is a Ubuntu, that's why. Okay, let me go with another one. Desktop, any other service. Let's say npm. You'll get most of the manual here. If you very really not understanding how to write it. Mostly you can find it over here. If you're not, it's not your job. It's a developer job again to create along with the repository. He will create a Docker file. But for the sake of creating a Docker file, he will just create a very sample file. Sample file, okay? Then it will get fail. Then he will come to us, to DevOps engineers. For the ML engineer, he will come to DevOps, like ML ops engineer. Then they'll tell us, hey, it is getting failed. What happens?
Just he will tell that which Java version is there.
We need to understand these paths exactly, or you need to arrange a code debugging session with the developer and check the logs, how,
Hmm.
which path it is going, from what it is copying, and what happening here. You need to sit and read this Docker file. Most of the time, if you read this Docker file, problem will solve.
Yeah, definitely.
You
It
need
will
to,
show which folder in the server we have to work. Suppose here OPT app. So first we have to log into server. We have to go to this OPT app.
hmm,
Then after this we have to clone the code and then the Docker file.
yes. So this is how we need to understand this. Docker file is just, see, it is a JDK, then these are the paths. So these are the things need to be copied. So this who will tell which one things to copy? Developer will tell. If you don't know, if you go to Stack Overflow or GitHub community, you'll able to find out. But these are very generalized things. Generalized things you will find out in the internet. But according to your repository, who will tell you? You're not a developer, right? So you need to make sure arrange a session with the developer, sit with him, and you need to read a Docker file. So that way it is highly effective and it will solve. If you are thinking yourself, I am right and it's my responsibility, it is getting failed, it will get failed only until you are don't know what to be copied and what to be executed. Sometimes the port number you are thinking is 8080. No, for that code, it is not the 8080, it's something. So you need to ask the developer. Okay, clear?
Yes, sir. Thank you.
Cool. So we'll continue from tomorrow. It's already 11:05 and I have to attend the sessions.
What exactly this Gemi, NPM, and SD? Can you just, in short, can you explain?
So these are the base images, okay? That means JDK, These you can call it as runtimes also. Runtimes means now I have a code. I have a code. Okay. So this code I want to convert into a image. What I need in between? I need a Docker file. Previously at 2018, what happened? In from you are going to call nothing but Ubuntu.
Yes, yes, yes.
Ubuntu. Inside the Ubuntu, you're creating a directory.
Yeah.
And
Creating a
inside
directory.
that you're copying. And inside that again you're installing run or apt install Python.
Yes, yes.
It's something like your EC2 instance. Inside the EC2 instance, you're calling one more EC2 instance and installing the Python, and then you're giving with the entry point run Python program.
Yes.
So what happens? Your main instance is 8 GB, but this is something 150 MB. That is the only difference. Nothing difference, okay? It's only difference.
That is why multi-stage build is coming to come.
Okay, so this is the case previously. Docker is highly automated, highly they developed much, okay, containerization techniques. Then gradually they find out something. It's creating a lot of MB, even though at 8 GB, if you're taking Ubuntu and doing this all, it's reaching almost 1 GB, 800 to 1 GB. Now, what is the point of doing this? It's something like virtualization, hypervisor only, right? So, to reduce this, to make more optimized way, we the now runtimes came into the picture. See, in this Ubuntu, I need to run all these run commands, run installations. Then my application will work. It will take longer time to be executed. Right? The execution time also more. Your CI/CD pipeline time also more. In resume, you are adding, right? I have reduced CI/CD pipeline execution time for 30% decreased. That is the point you are adding, right? Why you are adding that? Your pipeline is ideally need to run 4 to 5 minutes only, not more than that. If your pipeline is running multiple stages, if it is a Jenkins, it has to run hardly 10 to 15 minutes, not more than that. If a pipeline is running more than 25 minutes, then it is a timeout error. It should not be like this. It's eating the time of developers and your time and deployment time also. Should not be like this because it's taking some time. Every stage is going to take that much time. Then you cannot optimize the CI/CD pipelines. To make it optimize, the one stage is very crucial stage is this Docker building stage. Already my resources are using 8 GB and 1 GB it is consuming. So my node is having 2 GB used by the host operating system and 1 GB is used by this single image. And when I'm going to run it as container, it is using 500 MB. So how much will be rest? 4 GB or 3 GB, 3.5 GB. If I run one more container, it will go on. In one server, I can only able to run 2 containers. So hardware resources are more. This is what we need to optimize. Now what happened? Java in order to whenever you run in the Ubuntu, you need to install Java here. JVM, JRE are the runtimes. JDK, these are all the runtimes. So these are going to support to build your program. Hey, why are you pulling the Ubuntu and running all the settings? Now Java given that we will build to the latest version some runtime images which already trained with the Docker. So this image you can call it as base image. In this image, every dependencies, everything plugins, everything will be there. In this image, you can use it as a base image and copy your code into this image. It's quite easy to execute, right? it will minimize your most of the errors. Rather, you're going with like this. It's a traditional method. That's why these all images are available at Docker Hub open sourcely. Got it?
Yes, sir. Yes, sir.
Cool. Okay, we'll meet tomorrow at same time. Thank you, everyone. And just please respond to our admin calls and then add into the Google Classroom.